All right, hello, welcome back. In this video, we're going to be talking about the rhombi. Rhombi is plural for rhombus. Basically, doing the same thing that we did in the last video, just determining how to use segments of diagonals to determine if a quadrilateral is a rectangle, rhombus, or a square. So with the rhombus, we have every single property of parallelograms that are going to be the same. So we have opposite sides that are congruent and parallel. We have opposite angles that are congruent. Consecutive angles are supplementary. Diagonals bisect each other. And then we have three more that we're going to introduce specifically just for the rhombi. With rhombi, all four sides are going to be congruent. The diagonals will be perpendicular. And the diagonals will bisect the opposite angles. All right, so this first example here, we're going to go ahead and fill in what we know. This is a rhombus. So EF is 23. DF is 40. So this length here is 40. We're going to fill in the rest. The first thing that we're going to take a look at here is GF. Okay, so we go back to our properties of the rhombus, and we see that all four sides are congruent. So that means that GF is going to be the same as EF. That's going to be 23 as well. HF is half of DF. HF is half of DF. Because it is a diagonal piece, diagonals bisect each other. That means that HF is going to be worth a value of 20. Next up, they want us to find GH. So GH here in green. Now GH, remember what we said about the diagonals being perpendicular. So inside here we have a 90-degree angle. What that means is, if we take a look at this triangle right here in green, we are going to be using the Pythagorean theorem to solve for GH. So for GH, we're going to use the Pythagorean theorem to solve for it. So GH is a leg. So we have GH squared plus 20 squared, and that's equal to 23 squared. So GH squared plus 400 is going to be equal to 23 times 23, which is 529. GH squared is equal to 129. And the square root of 129 is 11.36. for GH. It means that going from G all the way to E is going to be double GH. So we just multiply this right here by 2, and we end up with 22.72. Right down here for number 4. For number 4 is a lot of the same logic as what's up here above, except we're just dealing with angles this time. The first thing that I'm going to do is mark up what we know. So we know that inside here we have 90-degree angles. That means that angle 8 is going to be 90 degrees because our diagonals are perpendicular. When they cross, they intersect and make a perpendicular angle. Okay. For angle number 3, we also know that all of the angles get bisected by the diagonals. So angle 3 is going to be 38 degrees. Okay. Opposite angles are congruent. So the opposite angles of the 3 and the 38 are going to be this 4 and 5. So 4 and 5 are also both 38 degrees. Okay, that leaves us with 1, 2, 7, and 6. So to find those, we have to use the triangle angle sum theorem. So for angle 1, I'm going to use this 90 degrees. So angle 1 plus 90 plus 38 is all going to be equal to 180 degrees. Angle 1 plus 128 is equal to 180, and that gives us a value for angle 1 equal to 180 minus 128, which is 52 degrees. It means angle 2 is going to be 52 degrees, and angle 6 is going to be 52 degrees, and angle 7 is also going to be 52 degrees because all of these angles are the same based on the properties that we have for diagonals. Okay, this next problem here has us dealing with sides. These are really straightforward and simple. This one right here deals with opposite sides being congruent. Opposite sides are congruent. And then this one right here, the property that we're using is that diagonals bisect the angles, okay? So here's the work that we're going to be taking a look at. See you in a second. All right, so here is our work that we are showing here. For number 8, we have 9x minus 77 equals 3x plus 7. That comes from the opposite sides are congruent. Solve for x, so we move all the x's to the left, the numbers to the right. We get 6x equals 84. Divide by 6, and x is equal to 14. Now at this point, okay, we're still trying to find MP, okay? And since we don't know what MP is, and we don't know what this opposite side of it is, ON, we're going to use the fact that all 4 sides in a rhombus are congruent. So MP, I just chose to use MN. MP is equal to MN. So we have 9 times 14 minus 77, which gives us a solution of 49 for MP. Now number 9 here, okay, we're setting 5x plus 1 equal to 8x minus 20. When we do that, we're just solving for x. I moved all the x's over to the left, which gives me negative 3x on the left. I moved the 1 over to the right, which gives me negative 21. Divided by negative 3 on both sides, x is equal to 7. Now our goal here is to find FED. FED is this large angle. FED is the large angle. So when I'm solving for that, what I need to do is I need to use this property right here. Okay, FED is supplementary with angle CFE. So when I'm doing this, I need to figure out what CFE is. And the way that I do that is I just take my 7 and I plug it in here and multiply it by 2. So CFE is equal to 5 times 7 plus 1 times 2. Okay, so that's 36 times 2, which is 72. So CFE is 72. And since FED is supplementary with CFE, when I'm solving for FED, I'm just going to take 180 and subtract 72 from it to figure out what FED is. So FED is 180 minus 72, which gives me 108 degrees. All right, that's it for the rhombus. In the next video, we're going to be talking about squares.